All right, so today we're going to take a look at adding and subtracting decimals, both with models and then converting into symbols as well. So one thing I want us to look at whenever we are adding and subtracting really anything or doing any sort of problem, we want to look at an estimation and figure out what would be reasonable. So a lot of times we might be asking just simply, would it be less than a half or more than a half, or even more than one or less than one, depending on the problem. So here we're looking at 37 hundredths plus 5/10. So we have an addition problem. When we're looking at this, if we're starting with 5/10, we know that it's going to be more than a half because we're adding, and we already have 5/10, which would be a half. But we know it's going to be less than 1 because we're adding less than half with the 37 hundredths. So what I'm going to do is I'm going to model my 37 hundredths first. So when I do that, remember 37 hundredths, we're going to start with tenths for efficiency, is 3 rows of 10 in red. And then we're going to have 7 hundredths in purple, but I don't have a purple pen, so I'm going to use green. Right, so there is my 7 hundredths. On my second block, I'm going to model my 5/10. So now when we look at the two of these, and we look at combining 37 hundredths plus 5/10, and we're going to think about how I can model it down here. So the most efficient place to start would be by adding or modeling in our tenths. So I have 3/10 for my 37 hundredths, 5/10 from the 5/10, and then I have my 7 hundredths that I'm going to put in here as well. And now we can see for total we have 0 as a whole, and then we have 8/10 and 7 hundredths. So this is how we modeled using, or how we show our addition using models. If we start to use symbols, what we're looking at happening is we have 0 and 37 hundredths, and what we're doing is we're adding 5/10. Now I know that some of you know that we line up the decimal points, and the reason we do that relates back to our fractions. We have to add numbers with common denominators. So when we took our tenths first here and here and added them together here, we're really putting together the common parts. So since there weren't any other hundredths, that's why we ended up with 7 hundredths in our answer. And then when we were adding the 3/10 plus 5/10, we got a total of 8/10, and so we're putting together those common pieces. So let's look at another example of addition. So now we have 1 and 6 hundredths, and we're adding 7/10. So we know it's going to be more than 1 because we are starting with more than 1 again, plus 7/10. Now we could ask ourselves, is it going to be more than 2 or less than 2? In this case, it'd be less than 2 because 6 hundredths is different than 7/10, so we're adding different sized pieces. So we're not going to have enough to get all the way up to 2. If you remember, 1 whole means that I'm going to fill in this entire square. Now I'm going to use tenths because tenths are the most are the easiest to use and also the most efficient to use. And then in my second square, I'm going to add in my 6 hundredths. Now because we're adding 7/10, this is going to be modeled slightly different. So what I'm going to do down here is I'm going to put my 7/10 just to kind of model. Now since we have 1 full square here, we know in our answer we're going to have one whole. And now what we're going to do is we're going to look at combining these two. So I'm going to take those hundredths and I'm going to place them with my 7/10. And so now, oops, too many. I see that I have the 7/10 that I started with plus another 6 hundredths for my first. So now I have 1 and 76 hundredths. And if we start talking using symbols, I have 1 and 6 hundredths, because remember with the 6 hundredths there weren't any tenths, so we just have a 0 there. And we are adding 7/10. So now when I add, there was no hundredths to add, there's no tenths to add, and really there were no ones to add. So it was really putting three different pieces together, and that's how we end up with 1 and 76 hundredths. So addition is pretty easy to visualize because you're putting pieces together. So now what's going to happen when we start to look at subtraction? Once again, we think about reasonableness of an answer. So if I'm looking at 56 hundredths and I'm taking away 9 thousandths, our answer is still going to be more than half, because 56 hundredths is more than half and 9 thousandths is just those itty bitty little squares, and we're not taking away a full square. So we're not taking much away from 56 hundredths. So what I'm going to do is I'm going to start with my 56 hundredths, which is really the same as 5/10, because we're talking efficiency. So I have 10, 20, 30, 40, 50. I'm going to add in my 6 hundredths. And now over on my other square, I have to take away my 9 thousandths. So when you start to think about how that's modeled, remember we take that square and we split it into tenths, and then using our blue, we're going to color in 9 out of those 10. So now when we look at this, we have 56 hundredths and we're taking away 9 thousandths. Now there aren't any thousandths to actually take away. So what we need to actually do is we look at this last box here and we take away 9 thousandths out of that 100th. So if we split that and I take this away, and remember at one point this box was full. So if I take away, you're really just left with 1/1000th there. So in the end, we are left with our 5/10, 5 hundredths that we haven't messed with, and then we have 1/1000th that remains here. So if we look at what we have modeled now, I have no holes, 5/10, 5 hundredths, and 1/1000th. If we look at this using symbols, and this is where it gets a little tricky in some of those other methods, but if you understand regular subtraction, what we can do here is we're going to add in a 0 just as a placeholder, because remember 560 thousandths is the same as 56 hundredths, and then we can use that concept of regrouping. So think about what we actually did. So what we did is we took one of those hundredths, so now we're left with 5, and we created a thousandth by making this, by cutting it into 10 pieces. So I had 10 pieces, and then I was able to take away 9, so it left me with 1, leaving me with just 5/10 here or 5 hundredths here, and then 5 tenths, which we never changed anything, and that's another way that we can have 551 thousandths. So real briefly, I'm going to go through one more subtraction problem, but I'm going to show you another method that you can use instead of taking away. So what we're going to do is we're going to use the concept of adding up. So I'm going to start with my second number. I'm going to start with 6/10, and I'm going to model that up here. And now what I want to do is I want to look at how much do I need to add to my 6/10 to make it so that I end up with 1 and 5800. So it's that concept of adding up. So instead of using my typical colors so that I can count, I'm going to use different colors. So first I'm going to get to 1 whole. And I'm just going to use black to show that. So here I have 1/10, 2, 3, 4. And now I need to get to 58 hundredths. So I'm going to add in 5 more. So at this point, I've added 9/10 because I had to add 4 here to create a whole. And I had to add 5/10 here to get to my 58 to get to my 50. And now I'm going to add in my hundredths, and I'm just going to still use black. And I need to get to 58, which means I'm going to add in 8 dots. So in the end then here, I added 8 hundredths, which I'll add here. So now my answer would be 98 hundredths. You could do the same model of taking away, but just another way to look at subtraction, another tool.